Hello, fellow hams and oggies from all around the world. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. And this one has to do with stringing up dipoles. Now, I have made the point multiple times that the optimum height for a dipole is a half wavelength. That can be pretty hard to achieve on the low bands, because like for a 40-meter antenna, that would mean a height of 66 feet, which is a bunch. That's real hard to do for most hams, unless you've got some really tall trees. But for 20 meters, a lot easier, 33 feet. For 15, even easier too, 7.5 meters, around 25 feet, and so on. So I got this question from Dan, K8NAK. He noted that you can make a fan dipole, but you got the same problem with the fan dipole. You've got everything up at the same height. Now, I did a supplemental video for an Ask Dave column in QST in October of 23. And you can look that up on YouTube. Go to the ARRL HQ channel and look for it. It's a video that describes making and installing a 4-band inverted V. And as it turns out, there's a lot of detail in that video about how to do it. But he's just not going to do that. Let's take a look at the whiteboard. A fan dipole fed at the center. And if this is for 40 meters, this is 66 feet. The 20 meter is half that, or about 33 feet. And then 10 meters is half that again. A half wavelength on 10 meters is 16-ish feet. Okay, that would be what it looks like. By the way, this works really well because each band is invisible to each other. You put in a 40-meter signal and it only sees one. These others present a high impedance. The one difference is on 15 meters. On 15 meters, it sees this as a 3/2 antenna, 3 half wavelengths, an odd number of half wavelengths, okay? So you don't really need to put up a separate element for 15 meters because the two, 15 and 45, will interact with each other. Now, let's look at what he's going to do. He's going to pole, and let's just assume this is a 66-foot tall pole. He's going to put in a dipole here for 40 meters and pull the feet away. It's going to go a half height. This is 33 feet. This is 33 feet. And he's going to put some rope in here and pull that away. And then that's the 20-meter antenna at its optimal height. And now we go with the 10-meter antenna, okay? And it's going to be half of that, okay? And this will be at 16 feet. Now he's got 3 separate antennas with 3 separate coaxes. And this in here is rope. Use UV resistant rope that doesn't stretch. By the way, that excludes parachute cord because parachute cord stretches like crazy to act as kind of a shock absorber to somebody. When the parachute suddenly inflates, it can put a real jerk on the body. So that's why they use that flexible cord. But you can get UV resistant, non-flexible rope. I just use 1/8 inch from DX Engineering. It'll handle several hundred pounds. Actually, it's pretty good. Now the question is, will this work? The answer is absolutely it will. It'll work just fine. Again, stuff you're putting in here won't interact with this and won't interact with this because these are the wrong impedances. If you put something in for 15 meters, you could put an antenna in here, but that would interact with the 40-meter antenna. Best just use the 40-meter antenna on 15. Now, do you need to do this? This would mean that the lobe of the radiation is going to look something like this. And over here too, okay? This is what I call the optimum angle. If you go higher than the optimum angle, what you're going to find for lobes is that you're starting to develop a second lobe. At a full wavelength high, what you're going to see is 2 distinct lobes. And yes, that's a deep null down in between them. And the higher you get more of these lobes with a deep null. And if that happens to be the right elevation angle for station you want to talk to, it's slipped through the cracks, literally. Okay? So this will give you the right lobe on every channel. Now note, 16 feet isn't very high. A normal house, yeah, the peak of the roof might be 33 feet, something like that. This will be down amongst the buildings and so on. So you'll have to play with it a little bit. There's nothing that says that these have to be lined up with each other. In fact, you can turn them this way. You can do the same thing with a center-fed fan dipole. Okay? And we'll put the code here for how to get to that video in the comments below if you want to watch that video. So Dan, I hope that helps answer your question and tells you what to do with respect to that antenna. Can you do it? Yes. Will it help keep it down to one lobe? Yes. Is it going to make much of a difference in your contacts? Actually, it'll make your contacts a little better. If you put everything up at the same height like a fan dipole, there are some lobes in there where you have very little return, but the ionosphere is constantly changing. And so a signal that comes up this way and comes down over here, a few seconds later it's going to go 50 miles past that and come down over here. So you see those lobes are going to be moving around on you as you operate. Okay, there you have it. Until we next meet, 73.